Gravity is an invisible force that is everywhere and affects everything around us. It's what makes apples fall from trees and keeps the moon orbiting the Earth. But what exactly is this mysterious force? To start, we need to understand the basics. The story of Isaac Newton is famous. He was sitting under an apple tree, saw an apple fall, and had an idea that would change science forever. He realized that the same force that made the apple fall was also responsible for keeping the planets orbiting the sun. Newton called this force gravity and created a formula to explain it. Basically, gravity depends on the mass of the objects and the distance between them. The more massive the object and the closer it is, the greater the gravitational force. Now, imagine two bowling balls on a trampoline. When you put one ball down, it curves around the trampoline. If you put another ball down, it rolls toward the first, right? That's pretty much how gravity works in space. Planets, stars, and even black holes bend the diving board of space, which we call space-time, and this is what makes objects move in their orbits. But gravity isn't perfect, and that's where Albert Einstein came in. He proposed a revolutionary idea. Gravity isn't exactly a force, but rather the result of the curvature of space-time caused by massive objects. For example, the sun bends the space around it, and this is what makes the Earth spin around it. It's as if space were a swimming pool, and the sun were a giant beach ball sinking slightly in the center. An interesting example of this is light. Did you know that light can be bent by gravity? Even though light has no mass, it follows the path of curved space-time. This was proven in 1919, when scientists observed that starlight appeared to bend as it passed close to the sun during an eclipse. This phenomenon was one of the first major proofs of Einstein's theory. What about astronauts floating in space? Are they far from gravity? Not really. They're being pulled by Earth's gravity all the time. But because they are moving so fast and falling toward the planet at the same time, it feels like they are floating. This is what we call free fall. If you jumped out of an airplane and there was no air to hold you up, you would feel the same way. Now, to understand gravity in a practical way, let's imagine the following. You are in an elevator in space. If the elevator starts accelerating upward, you will feel as if you are heavier. But if it starts falling, you will feel light or even weightless. This shows how gravity and acceleration are connected. Einstein explained this by saying that gravity and acceleration are actually the same thing. When you feel weight on the ground, it is because you are being accelerated by gravity against the surface of the Earth. And if you are in free fall, it is as if you are outside the range of this acceleration, even though you are under the effect of gravity. Finally, there's something fascinating called the tidal effect. This happens because gravity doesn't act equally on all parts of an object. For example, if you're standing near a black hole, gravity is so strong that it could stretch your body like spaghetti. This effect is what causes tides here on Earth, since the moon's gravity pulls harder on the water that's closest to it. Gravity is one of the most incredible forces in the universe. Without it, there would be no planets, stars, or galaxies. It's what connects everything from apples falling to the ground to black holes devouring stars. So next time you trip, remember, gravity did it. If you liked the video, don't forget to leave a like. This helps me a lot to continue bringing you amazing content. And if you're not subscribed yet, take the opportunity to subscribe and activate the bell so you don't miss any news. Your support makes all the difference.